Example 32. Find dy dx. For this parametric equation, x is in terms of t, y also in terms of t. In order to find dy dx, we will use chain rule. First, we will differentiate x with respect to t equals to 6t squared. Then we will inverse dx dt to become dt dx. Inverse 6t squared will become 1 over 6t squared. Next, for equation y, differentiate y with respect to t equals to 8t. Differentiate 1 equals to 0. Then, we are going to find dy over dx equals to dy over dt times dt over dx. The result of dy over dt is equals to 8t, and the result of dt dx is equals to 1 over 6t squared. Finally, we will simplify our answer. 8 divided by 6 equals to 4 over 3, and t can be simplified with t squared equals to t power of 1. Example 32. Find dy dx for this parametric equation. X equals to cos cube t, y equal to sin cube t. First, find dx over dt. Differentiate cos cube t by using power rule. Power move to the front becomes 3 times power minus 1 become cos square t times differentiate cos t equals to negative sin t, then differentiate the function t equals to 1. Simplify the answer equals to negative 3 cos square t sin t. Then we will inverse dx over dt become dt over dx. 1 over negative 3 cos square t sin t. For y equation, differentiate y with respect to t. Power move to the front, 3 power minus 1 becomes sin square t. Differentiate sin t equals to cos t, and differentiate the function t equals to 1. Therefore, answer equals to 3 sin square t cos t. Now, we are going to find dy over dx, where dy over dt times dt over dx. Next, we are going to simplify our answer where 3 can be cut off. Then sin square t divided by sin t. Then cos t divided by cos square t Finally, the answer will be sin t times 1 equals to sin t over negative cos t. Sin over cos equals to negative tangent t.